Good day to everyone. Good day to you. Good day wherever you are listening to Voice of Mathematics and Physics Dismantle channel. You are highly welcome to today's episode. But before I proceed, I want to appreciate our brother that just contributed supporting us concerning about these activities. The brother is happen to be a friendhood is a friend, is a childhood friend to us. We were together since all this while, and then he deemed it fit to support us, and we really appreciate him indeed. But our prayer is nothing but what may Allah continue to bless the brother and continue to reward him abundantly and manifold. Thank you so much, our dear brother. May God will continue to bless you as well. May God continue to support you in your own vision, in your own ambition, by special grace of Almighty. You are highly welcome, my brother today, my sister today, anyone that listens to me or anyone that watching this video. I really say thank you so much. You can be able to see my speaker. This is my speaker as you see it. You can be able to see my speaker here. This is my speaker, and you can be able to see that no side noise anymore, no more interference to this one. But not to waste much of our time, I want us now to back to the physics today. The mathematics is also is coming. Now let's quickly look at this physics. This is called a principle of moment. We want to see the moment of a force now. Then, what is moment of a force? We want to just embark on small calculation for those who did not understand the word, who did not understand it. And I want you to follow me as I want to do this. But before I proceed, my dearest brothers and sisters that are watching this video, make sure you share, like, and then remember, if you don't share it, who knows who will be on your own line, who will be on your phone, who will be on your own side that need this thing. Any moment you watch it, make sure you share it. I knew that you understand. I knew you know it. I knew you are not a dollar. I know you are an Efiko of the year. But what I'm saying is that what any moment you see this video, help us to share it. Just like it, and then forward it to another person who knows that your sister, your brother, even your friend might be able to gain one or two things here. One thing I believe is that what perseverance in doing everything brings perfection. Make us to perfect. The Lord will continue to bless and every one of you. Let's quickly look at it in a simple way. Let's go. Then what's the question? What question says? The question says that what a 50-meter uniform plank of weight 12 kg rests on to support at its end. A man of mass 60 kg stand 20 meters from one end. Calculate the reaction at the other end. This is a principle of moment. This is a principle of moment. Please make sure you comment. Whatever the words observation you observe on this video, please try to comment, and you can even send your question on my comment section. The Lord will be with you. Now let's quickly go and let's quickly see this solution. Solution is this. Now we are looking at this 50-meter uniform plank. Let's have it in this way. I have my plank this way. This is 50 meter. Let me call it what? 15 meter. That is my plank. I have it this way. Weight of 12 kg. Don't forget that your G is equal to 10 meter per second square. When we say weight cannot have a unit of kilogram. It is only a mass that has a what? That has a unit of this. But in terms of weight, you must recall that your weight is equal to mg. You don't you're supposed to understand that W equals to m is 12 kg given to you multiplied by 10 acceleration due to gravity. Simply means that what your weight is 120 Newton. That is the weight of the plank. Rest on two support. Then you have the first support here, and then you have the second support here. That is the two support. Don't forget that any moment you have this support, reaction will be taking place here. Then we have your reaction 1 and you have your reaction 2. That is it. And don't forget that they said that the weight of that plank is 120. The weight of a plank must act at the middle of this. Don't forget that what? The length of this thing is nothing but what? 50 meters. Simply means that what? You can have 25 meter here, you can have 25 meter here, which is going to tell you that what? Which is going to tell us that what? The weight of what? The weight of this thing is acting at the what? At the middle. The weight of this thing is acting at the middle. Now, to be continued, we've gotten the weight, which is 120. Simply means that the weight of this thing, weight of the plank, is acting here. To be continued, a man of mass 60 kg, a man of mass 60 kg stand 20 meter from what? From one end. The mass of that man given to you, telling us that what? The weight of that man also must be what? Must be calculated. Don't forget that the weight is mg. The mass of that man is 60 multiplied by 10 to give you 600 Newton. That is the weight of that man. The weight of the man, they said from one end is 600, but 20 meter from one end. Let me start from here. Simply means that what? You count 20 from here. Let's assume that the 20 count here. This is the weight of the man. From here to here is your what? Is your 20 meter. Don't forget that you left 5. You left with 5 meter here. I think you are getting the way I'm just analyzing it. Can you see? See how simple is it? Here, reaction 1, reaction 2. You have the weight of the man here. Don't forget that the weight of the plank must act at the middle. That one, sure. We don't dispute that one. Then the next thing is that then the man distance is what? Is 20 meter. Then you have the what? You have the distance of that man here. Now, that is the thing given to us. Now, what was now the question? Question now says that what? One, calculate the action at the other end. Calculate the action at the other end. See how simple is it now? What are the two principles of a movement, if you understand? The first one says that what? Total upward force must equal to the total downward force, provided that what? No any other constant, no any other problem, no any other factor that will put in place. That's number one. Number two, total clockwise of a movement must equal to the total anti-clockwise movement. The two are the things that we are going to use here. Now you cannot ask me, what are the upward force? What are the downward force? Good, and let's go. Now, R1, R2 is your upward force. Then look at the weight of a plank and the weight of the man. They were the one that called the what? The downward what? The downward force. Follow me as I said that what? The first one is going to be R1 plus what? R2 is equal to weight of the man plus weight of the plank. Then what are you going to write here? Total upward force is equal to total downward force. If you are following me, that is that. Now, R1 plus R2 is equal to this. Then you write it in this way. R1 plus what? R2 is equal to, what is the weight of the man that we just got now? 600. Plus, what is the weight of this plank? The weight of the plank that we got is what? 120. Add the two together now. 120 plus 600, that is 720 Newton. Simply means that R1 plus R2 is equal to what? Is equal to 720. That is for the what? Total upward force must equal to total downward force. Good and fine. The problem, then we continue. Having used that, having using that principle, let's go to the second principle, because they said we should look for the action at the other end. Now, we are looking at this now. If I want to take a moment from here, remember that if this one is acting this way, then all these two must act what? Opposite side of it. Then if I have something this way, that is clockwise. If I have something negating it, that is anti-clockwise. State the law that what? Total clockwise moment must equal to total anti-clockwise moment. What is my clockwise? It's going to be R2 multiplied by, don't forget the formula for the moment of a force. The moment of a force, the formula is force multiplied by perpendicular distance. That is the That is the formula for that one. Now, you see, it's very simple. If I've taken the R2, what is the distance of R2 now? It's taken from this to this. That is multiplied by 25 must equals to, then these two must be in the anti-clockwise. If I could be able to take this one, what do you think that this one will take? It is the half. It will take care of the 25 as well. That is 120 multiplied by 25 times 3 plus, that one is for this, plus because of the man as well. The man will take his own. What is the man is going to take? They have already given us that one. The man is 600 multiplied by, what is his what? That is 20. That is in like that. Simply means that you are looking for the reaction at the second side. At the end of the day, you only have this one, 120 multiplied by this. That is 12 times 25. We have 0, 1, 5, 6, 4, 2. That is 300. We have 300 plus this one will be 2 times 6. That is 12. That is, we have 12,000 there. We have 600. No. 5 times this, 0, you mean that one. 5, that is 6. 4, that is 2. 0, 0, 300. We have this one to be 300. We have 600. We have 600 multiplied by this 0, 0, 0, 0, 0. That is 12. We have 12,000. We have this one to be 12,000. Therefore, we have R2 plus 25 equals to 12,300. Then we subtract this one from this, and therefore we have R2 to be equals to this one will be the times 25. R2 times 25, we have it like that. Then this one will take its own. That is for 25. The whole of 1.5 all the time. And this one will be 1. This weight of the man is what is 600. Yes. And then you remove this one from it. That is 12,300. Yes. And this one is 12,000. Let's look at it very well. Okay, 1.5 million. And this one will give us this. This taking 25. This one will taking 1. We add it together. Right down. 600 plus 120. That is. These are 600. It is 120. And this is equals to this multiplication. This one will not be equal to 25 minus 0 is multiplication. Then we divide this one by 25. This will be given us what? Then we have 12,300 divided by 25. 5 here, 5. 5 from 12, 2. You mean that 2 in 23, 4 in 30, 6, 0. 5 here, 1. 5 from 24, 4. 5 times 4, 20. In 46, 9. 5 times 9, 45. In 10, 2. That is, this one is 492 Newton. That is the reaction at the second one. Simply means that what we have 492 Newton is this. That's all. Then when we have this reaction, they said that to calculate the reaction at the other end. The reaction at the other end is 492 Newton. And that's all. See the way we are doing it. And then when you subtract this one from here, you should be able to understand the word, the R1. Then to know the R1, but you don't have to calculate that, but I want to tell you to know the R1. Therefore, you use what? R1 plus what? R2 is equal to 720. Your R1 is equal to 720 minus 492. Therefore, your R1 will be equal to, this one will give you 8. This remain 1. 11, you have 2. This remains 6. Therefore, this one will give you 228 Newton. Simply means that what the reaction at the first one is going to be 228 Newton. while the R2 is going to be 492. When you add it together, it will give you what? 720. That is how to solve the problem under the principle of the moment. Can you see how this look like? And that is it. It's so simple. I can believe that. It's so simple. If you have any other things to do, then you can send it to me. Thank you so much for listening to me. Please learn and grow. That is the only thing. That is the only weapon that we can use to kill poverty. That's the only weapon that we can use to fight the poverty. Please make sure you educate yourself. Thank you so much, my dear brothers and sisters that listen to me. May God bless you. Thank you. Ẹ ṣé o. Now, kí n tó máa lọ lórí ẹ̀, gẹ́gẹ́ bí àǹfààní àwọn ọmọ Yorùbá 10:30 gbọ́ mi, moment ni wọ́n ń pelé, that is moment of a force. Ibẹ̀ ni iye tí a ti máa ti jàǹgbọ́ fa epo mọ́tò. Nígbà tí a ó mọ̀ rí pé tí ẹnìkan bá jókòó tá a bá gbégi lórí blọọkù, tẹnìkan jókòó níbì kan, tẹnìkan jókòó níbì kan, ṣé mọ̀ wípé tó bá ti tóbi jù yóò gbé ọmọ kékeré ṣubú ni, but tán bá ti lè balance láàrin àwọn méjèèjì, ṣé wá rí tí wọ́n ṣe yẹn nígbà tán bá